Today we're looking at notes M-2, 6 trig functions, ratios. You'll see why ratios in a minute. So we've talked about in geometry before sine, cosine, tangent, possibly cosecant, secant, and cotangent, which each of these is reciprocal of what it's across from. So the reciprocal of sine is cosecant, the reciprocal of cosine is secant, the reciprocal of tangent is cotangent. Where we get these from are thinking back to SOHCAHTOA. So if you're given an angle measure, whether it be theta or t, I want you to think of xy as a point on the unit circle. So if I ask you to find the sine of a certain angle measure, okay, where did y over r come from? Well, think about the triangle within the unit circle. So I'm always talking about this angle here, whether it be a little bit taller or a little bit shorter. I'm always talking about the angle within the circle. Okay, so where I got sine of theta equals y over r is thinking back to SOHCAHTOA. So if I'm talking about this angle here, remember that sine is opposite SOHCAHTOA, opposite over hypotenuse. So opposite over hypotenuse, y over r, the radius, where cosine comes from adjacent over hypotenuse. So again, if I'm talking about this angle within the unit circle, adjacent would be this over hypotenuse, so x over r, where tangent is going to be opposite over adjacent. So opposite would be y over adjacent, which would be x. So again, remember that the x and the y are the points that we found or derived on the unit circle, where the cosecant is the reciprocal of sine. So this is going to be r over y, reciprocate it. Similar here, similar here. Pay attention to the fact that, all right, x, y is in alpha order, just like cosine, sine is in alpha order. If you notice, cosine deals with x and sine deals with y. So alphabetical order. Cosine deals with x, sine deals with y. Whereas tangent, which is similar to slope, is really like our change in y over change in x. Okay, so let's talk about how we use this in math. So find all 6 trig functions. So if you're given theta is equal to 2 pi over 3, I've drawn this in already just to save time, you have to visualize where 2 pi over 3 is on the unit circle. So what I want to point out here is that I've drawn the unit circle with, pi over 2, 0, pi over 2, pi, 3 pi over 2, and then 2 pi, that full revolution. These, not to be confused with your 45-degree angles, these are your cutting it into thirds. So this is your 60-degree angle, this is your 120, and this is your 180, and then so on and so forth. So this point here on the unit circle, recall that this, when you're cutting it into 6, and you visualize those as well, these here, recall that these are your bad news, good news, so therefore this is your flip-flop, so it's good news, bad news. Now when I'm talking this one over here though, remember that that is the negative good news, comma, bad news, because this x value is negative but the y value remains positive. So again, we're really visualizing this triangle here within the unit circle. So if I ask you to find sine of theta, and be aware it'll always say sine of theta, not just sine. The theta is required. What am I asking you to find? I'm asking you to find the y over r. Well, r for the unit circle, that r is always going to be equal to 1. So really, in the unit circle, I'm pretty much just asking you to find y, something over 1, which would just be that something. So in this case, y. So what is the y value of this coordinate here? That would be my sine. Remember that sine deals with y, cosine deals with x. So sine of theta for this theta would be the y value of the coordinate here, which would be square root of 3 over 2. So the cosine of theta for this angle here would be the x value. So the x value of that coordinate would be -1/2. Tangent of theta would be y over x. So our y is square root of 3 over 2 over x, which is -1/2. So remember, when you have a fraction over a fraction, flip the second and multiply. Okay, multiply by the reciprocal. So multiply by -2 over 1. So this would be -2 over -2 square root of 3, over 2. So then the 2's are gone, obviously, so it's negative square root of 3. So let me go back and box these answers so you really know what the answer is, especially here with the one that I had to do work. Okay, so then the cosecant of theta, remember that is the reciprocal of sine. So I'm going to reciprocate my sine value, which was the y value. So I'm going to reciprocate the y value. So that is going to be 2 square root of 3. Again, you know you have to rationalize. So square root of 3 times square root of 3 to rationalize. So you'd get 2 square root of 3 over 3. That is the cosecant of theta. Remember that secant is the reciprocal of cosine. So in other words, the reciprocal of the x value. So that would be -2 over 1. And then cotangent is the reciprocal of tangent. So I'm going to look at here my rationalized version. So I'm going to reciprocate that. That would be -1 over square root of 3. And again, you have to rationalize. Times by square root of 3 over square root of 3, which equals negative square root of 3 over 3. All right, so 2 more examples here. So if I want you to find sine, cosine, tangent, etc. for t, the angle given as 5 pi over 2. So I've drawn this in, but let's talk about it. So 5 pi over 2. So remember, this is 0. This is pi over 2, 2 pi over 2, or pi, 3 pi over 2, 4 pi over 2, or 2 pi, 5 pi over 2. The coordinate here at 5 pi over 2 is the coordinate 0, 1. Okay, so if I want sine of theta, remember that sine is your y. Okay, so I want the y value, so that's just 1. Cosine is x, so that's 0. Okay, tangent of theta, remember, is y over x. Think about slope, change in y over change in x, so y over x. So 1 over 0, okay? 0 underneath means undefined, so undefined for that one. Okay, cosecant of theta is the reciprocal of sine, or the reciprocal of y. So reciprocate 1 and you still get 1. Secant of theta, remember, is the reciprocal of cosine. So cosine is like 0 over 1, or 0 over anything really other than 0. 0 over 2, you can think about it anyway, but 0 over 1. So if you reciprocate that, that would be 1 over 0. And again, you can't have that 0 in the denominator, so undefined for that one. Cotangent, think about what tangent was. It was 1 over 0, and reciprocate that. So 0 over 1, so that would be 0. All right. Last example here, given the angle measure of -3 pi over 4. So on this unit circle, I have drawn in, obviously, these basic angles here, but also, unlike example number 1, these are like our 45, splitting into 45 degree measures. So remember, you are going to count these in between. So if you think this is your starting point, and this is -3 pi over 4, so this is -pi over 4, negative 2 pi over 4, negative 3 pi over 4. So our coordinate here, remember these are our twins. So this one was square root of 2 over 2, comma, square root of 2 over 2. But in this quadrant, both the x and the y value of the twins will be negative. Because our x value is negative, we go left and we go down. So the coordinate here is negative square root of 2 over 2, comma, negative square root of 2 over 2. So sine of theta here, remember, sine is y. That's going to be negative square root of 2 over 2. And then cosine is our x, which is in this case the same. Okay, and tangent is y over x. So a fraction over a fraction, multiply by the reciprocal, so multiply by 2 over square root of 2, negative 2 over square root of 2. And what happens here? So a negative times a negative is a positive, as well as here those simplify, these simplify, so it's just 1. Simplifies to 1. Cosecant, recall, is the reciprocal of sine. So the reciprocal of y, so reciprocate the y value, or you can look at this answer here if you have it readily available. So it would be negative 2 over square root 2, and again you must rationalize. Okay, so you have negative 2 square root of 2 over 2. Simplify, it would be negative square root of 2. Okay, and then here for secant, again, you're going to reciprocate cosine. We already did it. These are the same values. The x and the y value are the same. Since we already did it here, let's not reinvent the wheel. We know that when you reciprocate this value, just like when you reciprocated this value, it gives you the same answer. So negative square root of 2. Last but not least, cotangent, reciprocate tangent. So when you reciprocate 1, it's still 1. So that's our answer there.